Are you all able to see my screen?
Yes, sir.
Okay. So just a quick recap of what we have learned till date. So we learned about the COM serve being the master server, having all the intelligence, storing the index, having its own backend database like SQL Server, Microsoft SQL Server, and also in the latest versions of COM serve, we have MongoDB also coming in by default. The moment uh, any customer buys ComServe or Commvault license, uh, no need to buy the license separately for the Microsoft SQL Server, which is in the backend. It comes inclusive. Then comes the media agents, which are the heavy lifters and the data movers. They are responsible for reading the data from the source machines, also called as the clients, and writing them to storage targets. Those storage targets could be tape, those storage targets could be any kind of network attached storage, object storage, or SAN systems as well. Any number of media agents can be associated with a single master server. In master server, we can build redundancy by having standby master servers as well, right? And automatically they will keep getting synced. And with a single primary, you can have any number of standby master servers as well. Okay. On the client side, multiple types of agents are available: database agents, Exchange agent, SQL agent, SAP agent, MySQL agent. Then for virtual environments, VMware, RHEV, Hyper-V, okay, OpenStack, Nutanix. These are the hypervisors it supports. And you can have for Windows as well as multiple versions of Linux. Legacy versions are also supported. And yesterday we spoke a lot about versioning. So there is two levels of backward compatibility between the master server and the media agents and the clients. Okay. So the master server can be two versions higher than the version running on media agent, version running on clients. And we also understood broadly from a conceptual perspective how the upgrade process actually happens, where does the binaries get stored, and how the binaries get copied onto the multiple machines over the network over specific TCP ports. Okay. So any questions until this?
No, nothing from me.
Okay, great. So let's go ahead. Now we talk about little bit about scheduling, because this is a very important concept in data protection and cyber recovery, because always you are referring to the data at a point in time in the past. Okay, always. And you will be seeing this data once the uh, restore is completed, which means it will be a time in the future. So proper scheduling is extremely important for any kind of cyber recovery or backup and recovery software. Okay. And there is a dependency of this scheduling with the underlying system clocks. Okay. So if the master server is installed on Windows machine, then whatever are the time settings on that Windows machine, that will get applied, and those are the timestamps that you will see in the logs, and that is the time that will be followed to put a time marker on each backup copy. Okay, exact timestamp. So scheduling is extremely important. Now when you are doing scheduling, you can have different kinds of schedules for different copies of data. Okay, like we understood in the beginning of our class and in the previous classes, that you can have multiple types of policies, right? And each policy can be different for primary copy. Each policy can be different for the secondary copy, the tertiary copy, the copy on the cloud, so on and so forth, right? And Commvault doesn't charge you additionally for those copies, right? And one of the things that you can define in those policies is the schedule. Okay. When do you want to run it? How frequently do you want to run it? Okay. And that is what is defined under this scheduler. Okay. Because it is very obvious you don't want people to keep on going and firing jobs manually for every copy. Everything should happen automatically, and it should give you like a timeline in the past. Okay. Yesterday at this particular time, this is when the backup job started. This is when it ended. And hence the timestamp on the data is the end time of that particular job. Okay. But when did the job, what point was it scheduled? That is defined in this schedule policy. And you can see that in the scheduler. You can also see what are the dependent copies here. Okay. And if any other jobs are also running apart from copies, like any backend data management jobs, like deduplication, like any replication jobs from one media agent to another media agent, so disaster recovery jobs, any scheduled reports, okay, that need to be generated and sent out to multiple support teams automatically. Okay. Any updates, software updates. Okay. You may have scheduled some automatic updates. Okay. Or the updates of repository in the backend. Okay. So all those things, right? All these activities which you need to perform with respect to data management and maintenance of the Commvault infrastructure and protection of the infrastructure itself. Okay, all those things can be defined in this place, and you can view it here. Okay, and in the left hand side, you can also see that this schedule policy. There is one where I'm pointing my mouse right now. Let me see if I can have a pointer. No, sorry. Okay, anyways. So this place, uh, schedule policy. Yeah. This is where you will make these settings. You will create new policy. You will change existing policies, so on and so forth. Okay. Any questions on this? No? Okay. Let's move forward. Now we talk about another concept called client computer groups. Now, many of you learned to Zabbix, right, and are doing a lot of projects. So you will see that when you're adding machines into that monitoring software, sometimes and many a times the customer wants to group them, right? They want to group them per location. They want to group them based on department. They want to group them based on their roles, like all database servers, all virtual machines, all Exchange servers, all domain controllers, like that, or all laptops, all Mac machines, all Linux machines running a certain version of operating system. So like this, right? That's for easy identification, and the customer will be in a position to define granular policies for each of these kind of machines that are there in the infrastructure. Okay. Now, how do you make those logical groupings here in Commvault? It is by using this concept called client computer groups. Okay. And this is where you can define, okay, all these parameters where you want this characteristic to be automatically identified within the list of clients that have been added into Commvault by installing agent and registering with the ComServe, okay? Or you want to do it manually, like you want to create your own group and manually add, and you define what should be those parameters, okay? Like version in a particular time zone, okay? Not been backed up for so many days, then there must be something wrong with it. So you should be doing certain kind of automation for such things, trying to restart the agent there remotely, those kind of things, right? So it makes management and identification, reporting, scheduling, doing granular activities much easier. Not only that, even for certain technical reasons as well, you would like to, manage a group of machines together. For example, let's say there is an ERP software like SAP or Microsoft Dynamics. Now, those, large software which handle volumes of data in sometimes in petabyte scale, they will have different layers within their software architecture. So they'll have the web layer or the where you will be able to access the console, the GUI. There will be the middleware where all the business logic will be running. And then you will also have where the data is being persisted. That's at the storage layer or the database layer. Okay. Now, sorry, as I said, network issue my end. Can you see my screen?
Yes, sir.
Yes.
Okay. In the interest of saving bandwidth today, I will switch off my video, okay, and try to explain the concept to you verbally. I hope that's fine. Great, thank you. So we were talking about environmental perspective also, right? So as I was saying that you will encounter, these big software which will have different layers, web layer, business logic layer, and the database layer. Now, from a disaster recovery standpoint, and from a business reason standpoint, and from a data consistency and data integrity standpoint, and even from a compliance standpoint, when you are doing a recovery of an entire complex three-tier application, all the copies of these three layers of data should have the same stamp, sometimes down to the millisecond. That means when you're taking a backup of the web layer at a certain point in time in the day, even the backup for the business logic layer, the respective files, the config files, okay, the cache files, the logs. Similarly for the database also, okay, all the different instances of the databases, their respective log files like the archive logs, the redo logs, the transaction logs, or any mem files or any cache files are there. All of them, all of these things, right, should reflect the same point in time in your backup copy. Some applications will have a tolerance that, okay, the web layer may be, even up to few hours behind or ahead in time, that particular copy versus the copy of data which will reflect a different timestamp for the business logic layer and the database layer. Okay. They can be different in some cases for some applications. But for some applications which are very, very sensitive to timestamps, especially financial applications like core banking applications, like trading applications, every millisecond counts because millions of transactions are happening. Our UPI system, okay, perfect example. There are so many things happening simultaneously, and each of them has to have a consistent timestamp to the data, and that is extremely important. Okay, and even when you want to implement that, okay, in the environment where you're trying to protect that data from disaster recovery, from accidental deletion, from sabotage, or even from a cyber attack perspective, these things need to be taken into consideration that the point in time of each copy of the data should be consistent across different layers. Okay. And one mechanism of implementing that is client computer groups. Okay. So you put all those VMs and all those machines which are pertaining to the same application in one client computer group. And then when you define the schedule policy for it, when you define the storage policy for it, it will automatically get applied on all those machines together. And when you run a, most importantly, when you run a backup job or when you run a restore job, you can fire it simultaneously across all those machines, reflecting the same point in time. Okay. Does this make sense? Any questions, any doubts? Or was it too complicated? No doubts? Okay, great. One of my college teachers used to say, though I did very few classes when I was your age, there is only two times when there will be no questions. Either you have understood everything or you have understood nothing. Just joking, okay?
I'll be part of
You
A.
guys are smart. Raveen, I know you will say that. Okay, now we get into the some lower level details of the data management part of it. Okay. So please bear with me. We are not getting into practicals as yet, but understanding these concepts are extremely important because they have huge financial, legal implications. Okay? People lose jobs. People are jailed, literally, okay, for mismanagement of data. So it's as serious as that. Okay? And there are huge, fines which are associated with, you know, mismanagement of data because this data is directly related to money. Okay. And hence, understanding the concept is also extremely important because that once you understand the concept, you will know what to do inside the GUI, in the CLI, and when you're doing these low level configurations. Okay. But if you don't understand the concept that why is it needed, what are its implications, then many a times I have seen, it causes few members of down the line. I will ask an example. Okay. Every media agent has a deduplication database in the backend. And the database has a fixed block size. It's 128 kilobytes. If you my, you know, Hey guys, sorry for the disruption. I was having certain network issues. Can you see my screen? Hello?
Yes, yes.
Okay. So the example that I was taking, uh, so there was this person who was working in one large service provider, a Japanese service provider. They have a lot of data centers in India, and they manage petabytes of data in each data center. Now, this media agent has a backend deduplication database, and it needs high performance storage. And if the amount of data is very high, and the changes are also very high on the data, and uniqueness of data is less, then this deduplication database keeps growing in the backend. And if it runs out of space, it goes and impacts your backup jobs, because it will say no space in DDB, waiting for storage. That kind of error, and backup jobs may fail. And if backup jobs fail, you will lose that point in time, because can't go back in time, right? We don't have a time machine yet. So if the backup job which was supposed to start at 8 and end at 10 now may never happen on that particular day, and the timestamp will never show what it was supposed to show, so you will lose. So what will happen is, you will have, if the regulator feels that this is not as per regulations, then they can impose fine on the bank or on that company. Okay, so a proper audit happens and all these things are checked. And hence, so what happened is, this guy, that DDP path was getting full. There was no space left on that particular drive. So he was a Windows level administrator also. So he knew a particular concept called uh, compressing a disk. We have that option, right? You go to C drive, right click, go to properties on that disk, right? Then you will see compress disk to save space. One checkbox will come, right? If you go and click that checkbox, yes, logically you will see more space. But how is it getting that more space out of the same physical capacity? Is it is running something called as compression, okay, LZ compression on the data fragments. And there the sector size and the block size gets used. And I have explained this in my data center fundamentals class. Okay. Uh, so what this guy did is, he went right clicked and said, "Oh, don't worry, we will just get space within few minutes. Just wait and watch." And without going through a change management process, without asking anyone on that particular media agent, this man went and right clicked and said compress drive, okay, and clicked on OK. And that's it. It created havoc. That night, all the backup jobs on that particular media agent failed, because the operating system disk IO services was so busy in compressing the deduplication database of Commvault that it could not allow any other new writes to happen. Okay. And that's it. So that's the reason why, just because a particular option is available to you and you can see it on the screen, and it's as easy as just click and press OK, that each individual action of yours definitely is audited. Okay, there is an audit trail created as to which user made this change at what point in time. So you will get caught any which ways. But at the same time, you stand a chance to lose data and be not compliant. Okay. And that is the reason why it's extremely important for you to understand the implication of a single click or changing a value here and there, or selecting the wrong path, and all these things. These are extremely high impact actions. It may look very easy to do on the screen. I mean, you're not lifting weights, you're just clicking the mouse. But you need to understand the value of each click. Okay, it can have a detrimental impact and a huge, cost organizations. So you have to be extremely careful about data. So this particular GUI, if you remember in our previous classes, we spoke about something called as an index cache and the process called indexing. Now, what exactly is indexing? Indexing means uh, creating an index, right? So the best example I can give you is a dictionary, right? There are two ways you can search for a particular word in the English dictionary. What is that way? The first and the normal way is you understand, you know, you know the sequence of the alphabet. So you go and first check what is your first letter, go to that section, then you go to the second letter, go to that sequence, so on and so forth. Okay. That's the normal way. That's the sequential way. But it's going to take time, right? So what is the quickest way to go and find for a particular word in a dictionary? Instead of going the traditional way from the front, you go from the back. Why? Because an index has been created there, right? It's like a shortcut. It's a shortcut to the data that you want to search, right? And hence, this concept of indexing on data is extremely useful and extremely handy for any data management software. And hence, every data management software, including Commvault, has something called as an index cache. And there is a process that runs called as an index engine, okay, whose job is to do that. Whenever this media agent is reading the data from the source in certain chunks, like in 128 KB chunks or 256 KB chunks or 512 kilobyte chunks over the network, and reduplicating it, okay, and then writing it to a storage system that is attached to it as a machine, okay, in this entire process is indexed, okay, and each chunk of data can be identified if you could go and do a query in this index cache. So the software will exactly know where to pick up that data from, which storage it was, on which hard disk was it, okay? What is the location of the platter, the track, the sector, okay? The LUN number, the storage identification, everything, okay? All of those details about a particular data chunk, which was backed up from the source to a storage target. This entire index cache is going to have this information, okay? Okay, where this is going to be stored, okay? You select the path on that particular machine, okay? And if you're bringing it offline for audit reasons, as I told you, it's extremely important. You have to write a reason for bringing it on offline, okay? And then, so it's a little bit blurry, you can set up certain retention period for it and a disk cleanup percentage. Happens is data copies keep getting expired over a period of. Now, if a data, what is the need to keep is relevant index in the index cache? Okay, you can as well erase it and allow space for new data's index to come in. In that way, you can control the size of the index cache, right? And you need not have huge amount of storage for it. You can have some optimal storage for it. Okay, so that is the reason these disk space related certain settings are available at the media agent level, which will allow you to control the behavior of retention of data within the index cache. Okay, to control its size also. Then on the left hand side, this is again an extremely important setting which has a lot of legal and financial implication. Okay, which are these two settings: validation of data on media and validation of data on the network. Okay, so let me explain the network part first, and then we will come to this particular setting called validation on media. Okay, so when we talk about validation on network, what exactly does this do? Okay, when we are reading the data, and what are its legal and financial implications? Let us try to understand. As I told, there are different sectors and different kinds of companies for whom data is money. Okay, classic example is stock exchange, right? Physical money? Hell no. It's all virtual. It is data on machines, right? That's all it is. Okay. So, and what are they doing? They are trading. Okay. They're asking people to put in their hard-earned money. They're giving that money to companies. Companies are using that money to do something, and the cycle of financial wheel goes on. Okay. Any disruption in that wheel is going to cost someone, a lot of money, right? So people try to ensure that that someone is not them. Okay. So what they will try to do, they will always try to protect themselves, one, from data loss, second, from data corruption, and third, from cyber attacks. One way of doing it is CRC checks. What does CRC stand for? Cyclic redundancy check. Okay, it's a very simple algorithm that is run at the data chunk layer. You remember I told you that when a media agent is reading the data from the source, it is reading it not like a complete file one at a time. It is breaking down that file into chunks. And you can define that chunk size. Okay. 128 KB, 256 KB, 64 KB, 32 KB, like that. It will be in multiples of 2 to the power something. Okay. Because that's how, data architecture is. Everything is 2 to the power something. Okay. Now, when you're reading that data from the source, and when it is coming and landing at a particular storage, layer. So let me go back to this diagram. Maybe then you'll visually understand it better. Yeah, this one, right? So I am reading data from the source using a client agent software. So it could be data sitting on C drive, it could be data sitting on a particular mount path, a database, whatever it is. That data over the network, over the LAN, over those 10 gig, connections or 1 gig connections, which you connect physically to the server, right? Over that network through the switch, it is coming and landing or hitting these machines called as the media agents, right? Again over the network, and from the network again the data flows into the application layer, and from the application layer it goes and gets written onto the disk storage layer, right? Multiple kinds of storages: tape, disk, cloud, object storage, NAS. Now, who guarantees, okay, who guarantees that whatever you read from the client is exactly equal to what is written onto the storage in this media agent? Who is going to give you that guarantee? Corruption of data can happen from any point, correct? It could be due to a bad media on the storage itself. It could be a virus sitting on the client machine. Okay, it could be a man in the middle attack, some Trojan horse in the switch which is connected to this client and this media agent, right? Or it could be some kind of a software issue on the media agent when it is writing data to the storage, right? So in this entire process, there is so many chances of data getting corrupted, the same data not being written. Now, what is the implication? The implication is if the data being written itself is not correct, when you're going to restore it, obviously it will get it will not get restored, or whatever will get restored will be incorrect and unusable. Then what is the point in spending so much amount of money in backing up this data? All that is like gone down the drain, right? So in industries and companies where data is directly equal to money or data is into some thousand times the money, okay, this data validation is extremely important because they have to show the auditor, they have to show the public that boss, whatever I've recovered for you is exactly what was written. Okay. So the first level of validation happens on the network side of it. So when the client agent is reading the data from the source and when it is sending over the network to the media agent software sitting on a different machine on the network, it is also sending this CRC checksum. Okay, it's called as a checksum. Okay, for each and every data chunk, along with each and every chunk, it's like it's adding a tag, a kind of an identity tag, which is arrived by certain algorithm run on the bit and byte sequence of that data chunk. Okay, it's also called as hashing, and certain algorithms are there for hashing. So this happens on the fly while the data is being read before it is being put using that TCP/IP protocol, that layer 7, layer 6, layer 5, layer 4, all the way till layer 0 onto that wire. Okay, this checksum gets created, and along with that chunk, the checksum is also sent onto the network so that once the media agent process on the media agent server receives that chunk, it is also receiving an additional packet of data called as the CRC checksum. Okay, and it validates this checksum through the COMSER server. That was, is this the same checksum that you saw? Okay, when the data was being read, and now I have received it. I have this checksum with me for this particular data chunk. Is it matching? Yes or no? If it is matching, then perfect. The validation on the network for that particular data chunk is successful, which means whatever I read from the source, byte to byte, okay, bit to bit, sorry, and hence I can use this data now to permanently write it to or give it to the next process, which writes it to the backend storage, like the tape or the disk or the cloud, the SAN, whatever that is, irrespective. Okay. Understood? Any questions? What is meant by CRC check? What is meant by validation on network? How it happens? Are you able to visualize?
So, whether it does encryption or directly the
No, it does
how does
not
it happen?
encrypt. No, no. Encryption, we have not come there yet. That's a security layer. That's
Okay,
different. Okay,
Okay,
this is
okay,
only to check the integrity of the data and consistency of the data.
okay. Got it. Thank you.
Okay, yeah. Any other question? Okay, now we move to the next stage. What is the next stage? The next stage is validation on media. Now, just now we understood how each and every data chunk is being read from the source, travels all the way onto the network through the, you know, Ethernet cables, the switches, then lands onto the media agent. And once the media agent process and software reads that data, it validates it, and then it says, I got it. Now it sends it to the next process. Now, what is that next process? That next process is the process that writes the data which it has received onto the from the network onto the disk storage by deduplicating it, by compressing it, maintaining an index of it. So all these processes will happen now. Okay, this is the stage now, second stage. Okay, and here is where again another CRC check can happen. Okay, for each and every data chunk, whatever is the chunk size. Okay, and this chunk size of the process, which is writing the data to storage, may be different from the chunk size that was used to read the data from the network and from the source. Okay, let me give you an example. Let's say I'm reading the data from a Windows 2012 server. Okay, its C drive is there, its E drive is there. Okay, C drive, let's say 500 GB, E drive, let's say 1 terabyte. Okay, and X amount of data is there on that. Now, when I'm reading all that data using my agent, okay, let us say I am reading it in terms of 128 kilobyte chunks each. Okay, and I'm sending it over the network by doing some kind of compression, and so that it the data travels faster. You're able to complete the job faster. But once it is received at the media agent layer, the kind of network connectivity from the media agent to the storage can be completely different. It may not enjoy the same amount of bandwidth which the network between the client machine and the media agent machine may have. Okay. Classic example being, let us say I am writing a copy from my on-prem media agent to Amazon S3 storage or Azure Blob storage. Okay. That storage is not there in the data center. No, it's there on public cloud. That means what? There is a network connection that is happening from inside the data center, the media agent machine. A secure network connection is being established from the network machine to the switch, to the firewall, from the firewall to the internet, from the internet to, let's say, Amazon data center. In the Amazon data center, again going through all those layers, reaching a particular machine on which that data fragment is being stored. Okay. So all this Ramayana and Mahabharata is happening. Okay. Again, here the bandwidth in the data center can be 10 gig, can be 40 gig, but this, when you get 1 gig, it's a privilege because it's extremely expensive bandwidth. Correct? So how can I have the same chunk size? Because see, are you seeing the implication? If every 128 kilobyte of data that I'm reading from the source from the network, I have to create a checksum which is going to take time. Then once I've received it, Again, I have to, read it. It's going to again add a few nanoseconds or picoseconds. Okay. Then the network itself, right? Earlier it was only 128 KB, but now when I'm putting the checksum, another 8 KB is getting added. So now the total packet size is getting increased from 128 KB to 136 KB. Now, if it was just 10 or 20 or 100 packets, it's fine. Now we are talking about millions and billions of packets. All these additional 8 KBs will add to a substantial amount of, but your physical bandwidth has not increased. It is that much only. That means the efficiency of your network due to doing this is reducing. That means your data transfer time is reducing. Now imagine this happening on a 10 gig network itself. So much amount of overhead is coming up. If we do the same thing on a 1 gig network, do you think we'll be able to complete the backup job on time? Never. Because in a day, you have only 24 hours. So you cannot have the same chunk size being written and doing this Ramayana and Mahabharata on every small, chunk size. It's going to add so much amount of overhead that I will never be able to complete a backup job on time. And hence that copy of data will become irrelevant. And all that money spent on bandwidth, on storage, makes no sense now. Okay. So this is the implication of these kinds of settings, right? So when you're setting up the chunk size for the process that is writing the data from the media agent to the storage system, that chunk size will be completely different. It will be larger. It will not be 64 KB, 32 KB. It will be much bigger. Okay. It will at least be 512 KB and higher. So there will be a process which will collate these chunks and make multiple 128 KB chunks into a large 512 KB chunk. Okay. And since the chunk size is changing in this handover of data from one process to another process due to all these reasons that I indicated, okay, you cannot have the same CRC again. Very obvious. The CRC checksum that is now going to be generated for this new chunk size and is going to be different. And there is a process which will check, okay, what chunk size, when I'm creating the chunk size on the process level, what is the checksum? And when it is writing to the underlying storage system, what is getting written? There is a small process which will quickly read that chunk what has been written onto the storage. Okay. And it will quickly validate, okay, the process which wrote that chunk onto the storage, this was the checksum of that particular chunk. And this small, tiny process, its only job in life is to do this. Okay. Whatever was written, quickly read it back, check the checksum again. Matching, then perfect. Valid copy of data chunk written onto the storage. Nahi, it has not happened. Okay. Create that chunk again, write that data chunk again. So that's the importance of these two settings. Okay. It allows you to financially and from a compliance perspective, perfectly validate each and every data chunk that has been written. And hence, you know, you can tell the regulators, you can tell the auditors that yes, this is a perfectly clean, valid, integrated, reviewed, checked copy of data, and hence the restore is absolutely flawless. Okay, you can claim that. But at the same time, this processes bring in so much amount of performance, capacity, and cost overhead onto the entire infrastructure. So these two checkboxes may look very let's see what happens. You may lose your job the next day. That's what will happen. Okay. So they may look very simple, they may look extremely easy for you to go and just click, okay, and then click OK on that. But you're going to start such a cyclone or a typhoon which is beyond your control. Because once this process starts, it takes again certain period of time to again stop that process, because millions and billions of bytes of data are being written continuously on these systems. Okay. So once you start a process, because data is flowing at such a high rate, it just flows, right? Like what happens during floods, right? It just flows. Now to stop that humongous flow and to make changes on the fly, it takes time. So even if you just check it, click on OK, array, I did a mistake, let me go back and uncheck it, already damage is done for certain X amount of data. Okay, it's beyond your control. So every change that you make will be audited. Okay, an audit trail will be there for making that change in that infrastructure. And hence, when you're doing, you taking the okay, and that is the importance and criticality of just these two settings called as value. Second, this is how it happens. CRC checksums. Okay. Any questions? We'll talk about this V1 and V2 later. They are for performance improvement. So V1 was some older algorithms were being used, but then later that was causing performance issues, and hence this V2 kind of indexing came into picture, which improved the performance of the indexing processes, reading and searching. Okay. So a lot of documentation is there about this in documentation.commvault.com. Okay. Customers, and we also can go and read about it. So if you guys are interested, please do spend time on it. And if whatever you're learning here sounds interesting and you're able to relate to the criticality, uh, I'm sure you find it exciting and you'll read more about it. Okay. So yeah, that's what I had for today. I'm extremely sorry for the network issues. This was not anticipated. I'll try to rectify it from the forthcoming classes. My sincere apologies. Any questions? Due to the network down issues, I'm ready to spend more time with you people today. So any questions you have, please feel free to ask.
Nothing from me.
Sorry, Praveen, you were saying something?
No, no, nothing from me. No questions from me.
Okay, okay, great. Okay. So guys, just give me a thumbs up if you're able to follow, if you're able to understand, or is it like bounces over your head? Awesome, awesome. Great, great. Okay, wonderful. Thank you so much for the acknowledgement. I really appreciate it. See you all tomorrow. Good night.
Thanks, Sudeep. Hey,
Thank you.
Okay, sir.
thank you. Bye.
Thank you, sir.
Thank you. Bye.